Cetaceans were an entirely aquatic group of mammals that include whales, dolphins, and porpoises. Although they live in water, they breathe air, give birth to live young, and produce milk, which classify them as mammals. Throughout history, they were often confused with fish due to their aquatic lifestyle. Modern cetaceans are divided in two main groups: baleen whales, Myceteti, and theta whales, Odontoceti. Both groups evolved from early terrestrial ancestors such as Pachycetus around 50 million years ago during the Eocene period. Good day, audience and scientific community. Today we are going to talk about the evolution of cetaceans as an extraordinary group of marine mammals that transitioned from land to water. Through this presentation, we will explore how evolution shaped their bodies and allowed them to adapt completely to aquatic life.
Well, as Manu mentioned, cetaceans are marine mammals that live and evolve over millions of years. They story begin with Pachycetus, an early four-legged mammal that lived near freshwater environments about 50 million years ago. It looks similar to a wolf-sized animal and hunted fish near river, shallow water. Even even though it walked on land, its skulls already show early whale-like characteristic, especially in the near bones.
Thank you, Isa. Now with this information, we can tell that, well, over time, those animals were to adapt more to the side of swimming life and other of this stuff more than the life of land, running and hunting earth animals. So, well, if we were about the picture timeline, for first, we have the Pachycetus, that was an animal that had four limbs that were mostly adapted on Earth to be as fast as he could on land. And then we will have second in timeline Ambulocetus, that, well, it was an animal that was adapted for both water and land, but mostly developed on land, even if he could swim very easily and he had no problem with it. Then we will have the Rhodcetus, that, well, it was an animal that could go out to land, but he wasn't really like good at it. He was more like a swimming guy, and yeah. And finishing, we would have the Basilosaurus, that, well, it was the most early ancestor that we have of modern day whales. So yeah, that was pretty much the picture of the timeline that we would have if we were about to represent the evolution of Pachycetus to whales. So let's remember it: Pachycetus, Ambulocetus, Rhodcetus, and finally we would have Basilosaurus, that are pretty much modern day whales.
How did cetaceans evolve? The evolution of cetaceans involved major anatomical transformations. One of the most important changes was the movement of the nostrils toward the top of the head, forming what we now call the blowhole. This allowed whales to breathe more efficiently while swimming.
Another major transformation occurred in their skeleton. The pelvis became reduced and disconnected from the spine, reflecting the loss of function behind the limbs. Their vertebral column adapted for up and down movement, unlike fish, whose body moves side to side. This vertical movement reflects their origin as land mammals.
Okay, so good morning. In today's session, we're going to talk about cetaceans. And, well, for first, what are cetaceans? Cetaceans are any animal that falls under the group of animals that are aquatic, produce milk, have fur, and reproduce through giving birth to their children. And, well, when we think about some examples of those animals, we can think about dolphins, whales, porpoise, and other animals that are very well known. And, well, today we're going to talk about the origins of these animals. So we're going very back in time to about 50 million ago with Pachycetus, that was in the Eocene period. And, well, right now we're going to introduce you to my partner Manu. So thank you.
Well, The fossil record strongly support this evolutionary transition. We see a clear progression from Pachycetus to Ambulocetus, Rod- Rhodhocetus, and finally Basilosaurus. Each fossil shows intermediately characteristics between land mammals and mother whales.
Comparative anatomy also supports this process. Modern whales still remain small vestigial pelvic bones, evidence of their terrestrial past. Additionally, their specialized ear structures connect them directly to early ancestors like Pachycetus.
So, as my partner said previously, from this we can conclude that those events had an impact on the way whales reproduced and they spread to the world. So this actually led them to reproduce more around the world and spread towards more oceans and almost every marine ecosystem. So now we're gonna go with the conclusions with my partner Manu. So that's it.
Speciation event. As early cetaceans adapt to different aquatic environments, some populations became isolated. This reproductive isolation allowed different species to evolve separately.
And over time, environmental pressures such as ocean cooling and change in sea levels influence body size and migration patterns. Large individuals with greater energy reserve were better suited for long distance travel and survival.
So as my partner said previously, from this we can conclude that those events had an impact on the way whales reproduced and they spread to the world. So this actually led them to reproduce more around the world and spread towards more oceans and almost every marine ecosystem. So now we're gonna go with the conclusions with my partner Manu. So that's it.
In conclusion, cetaceans represent one of the clearest examples of macroevolution. Their transition from land mammals to fully aquatic marine animals is supported by fossil evidence, comparative anatomy, and genetic studies. This evolutionary journey demonstrates how environment pressures and natural selection can profoundly transform species over millions of years and generations.